In this video, we're going to find the area of basic shapes. First, we'll define what we mean by area. We start off with a square, which is 1 unit long and 1 unit wide. I'm going to use centimeters because it's a unit of length that people are familiar with. This square will be our unit of measurement for area. We define its area to be 1 square centimeter. These 3 lines mean that we are defining or declaring the area of the square to be 1 square centimeter rather than figuring it out. It's similar to what happened when you were born and your parents gave you a name. They didn't figure out that your name was Mia or Dawood or Parizota. They defined your name to be Mia or Dawood or Parizota, and so on. Anytime we are looking for the area of another shape, what we are really trying to figure out is how many square centimeters fit inside it. Let's start with a rectangle. This particular rectangle is 4 centimeters long and 3 centimeters wide. How many square centimeters would fit inside this rectangle? If we split the rectangle up, we can see that we have 3 rows of 4, or 4 columns of 3. The number of square centimeters that fit inside this rectangle is 3 times 4, or 4 times 3. This same reasoning applies to all rectangles, not just a 4 by 3 rectangle. In general, if B is the base of a rectangle, and h is the height of a rectangle, then the area is equal to the base times the height. In this equation, the letters REC stand for rectangle. The equation reads, the area of a rectangle is equal to the base of the rectangle times the height of the rectangle. Let's try to figure out the area of a parallelogram. Here, the letters PAR stand for parallelogram. Given any parallelogram, we can slice off one end and attach it to the other side. The area is the same as before, and we can see that the new shape is a rectangle. So the area of the original parallelogram is equal to the area of the rectangle that we made from it. But we know how to find the area of a rectangle. It's just base times height, so we can plug that in. Right now, the area of the original parallelogram is written in terms of the base of the rectangle and the height of the rectangle. That's not really what we want. Let's see if we can write these in terms of the base and height of the original parallelogram. Here's a duplicate of the original parallelogram. What is the relationship between the base of the parallelogram and the base of the rectangle? And what is the relationship between the height of the parallelogram and the height of the rectangle? We can see that the base of the parallelogram fits perfectly over the base of the rectangle. The two are equal. The height of the parallelogram is also equal to the height of the rectangle. Therefore, in our equation, we can simply replace the base of the rectangle with the base of the parallelogram and the height of the rectangle with the height of the parallelogram, since both bases and heights are the same. So the area of a parallelogram is equal to the base of the parallelogram times the height of the parallelogram. Just like the area of a rectangle was equal to the base of the rectangle times the height of the rectangle. It's important to remember that the height of a parallelogram is perpendicular. In other words, it makes a right angle with the base of the parallelogram. For example, let's say this is 6 centimeters long. This is 4 centimeters long. And this is 3 centimeters long. The area of the parallelogram would be 6 centimeters times 3 centimeters, which is equal to 18 square centimeters. Why didn't we use the 4? Because the 4 was not perpendicular to the base. The 3 was. Therefore, the height of the parallelogram was 3 centimeters, not 4. 4 was simply the slant length of the parallelogram, which is not used in the area formula. Let's try to figure out the area of a triangle. For this proof, we're actually going to begin with a parallelogram. If we imagine slicing the parallelogram from corner to corner, we can see that we get a triangle. I'll go ahead and pull this triangle out. We can see that the area of the triangle is exactly half of the area of the original parallelogram. Since we know that the area of a parallelogram is base times height, we can plug that in. Now the area of our triangle is written in terms of the base of the parallelogram and the height of the parallelogram. That's not really what we want. We need to figure out the relationship between the base of the triangle and the base of the parallelogram, and the relationship between the height of the triangle and the height of the parallelogram. By putting the triangle back where it was, we can see that the base of the triangle is equal to the base of the parallelogram, and the height of the triangle is also equal to the height of the parallelogram. Therefore, in our equation, we can simply replace the base of the parallelogram with the base of the triangle, and the height of the parallelogram with the height of the triangle. Because again, both of the bases and the heights are the same. So the area of a triangle is equal to 1/2 times the base times the height. Since multiplying by 1/2 is the same as dividing by 2, we can write this equation another way. The area of the triangle is equal to the base times the height divided by 2. Finally, let's try to figure out the area of a trapezoid. Once again, we can start with a parallelogram and slice it in half to obtain a trapezoid. This is similar to what we did for the triangle, except we are not slicing from corner to corner. The area of the trapezoid is 1/2 of the area of the parallelogram. But the area of a parallelogram is equal to the base of the parallelogram times the height of the parallelogram. So we can plug that in. Furthermore, we can see that the height of the trapezoid and the height of the parallelogram are equal. So we can replace the height of the parallelogram with the height of the trapezoid in our equation. However, the base of the parallelogram is not equal to the base of the trapezoid. There is a missing piece. Actually, trapezoids have 2 bases. Let's call the bottom base base 1, and the top base base 2. We can see that the missing piece is equal to base 2. We know that because of how we got our trapezoid in the first place. Remember, we cut the parallelogram in half. So in fact, we got 2 identical trapezoids. Now we can see that the base of the parallelogram is equal to base 1 of the trapezoid plus base 2 of the trapezoid. Let's plug that into our equation. So the area of a trapezoid is equal to 1/2 times the sum of the bases, base 1 plus base 2, times the height. Again, multiplying by 1/2 is the same as dividing by 2. So we can also write this as the sum of the bases times the height divided by 2. Have a great day.